Hello and welcome to Module 1. In this short presentation, I will address the following: the physiological effect of the neurotransmitter gamma-aminobutyric acid, which throughout this presentation will be referred to as GABA, and how GABA affects neuronal excitability, the effects of benzodiazepine at GABA receptors, along with the implications of combining Valium and alcohol, and also the role of chloride in skeletal muscle and one of the channelopathies that affect the role of chloride. GABA is an amino acid that acts primarily as an inhibitory neurotransmitter within the central nervous system and is involved with respiratory rate. For GABA to be released into the synaptic cleft, an action potential must be received at the presynaptic cleft. In the cytoplasm of the presynaptic nerve, GABA is synthesized from the precursor glutamine. Glutamine is catalyzed by the reaction of which is caused by the enzyme glutamate decarboxylase. So, this action potential opens the voltage-gated calcium channels once it arrives at the presynaptic cleft, resulting in the synthesis and release of GABA into the synaptic cleft. GABA then binds to the receptors of the cell. There are two receptors GABA may bind to. These are ionotropic receptors, which are also known as GABA-A, or metabotropic receptors, which are also known as GABA-B. Looking into GABA-A receptors, these ionotropic receptors reduce the excitability of a neuron when inhibitory neurotransmitters bind to the receptor. This causes the chloride channels to become more permeable to the chloride ion. As chloride ions are released, this causes hyperpolarization of a membrane potential. This initiates inhibitory postsynaptic potentials, therefore inhibiting action potentials. However, certain medications may alter the activity of these GABA-A receptors, such as benzodiazepines. Benzodiazepines are a robust example. They exert synergistic effects on the central nervous system. Benzodiazepines attach to ionotropic receptors, which influence the effect of GABA-A action on the receptor. They rearrange the frequency at which the chloride channels open, therefore increasing chloride ion permeability and subsequently initiating less action potentials to be fired. As both Valium and alcohol attain the same mechanism for neuronal excitability as the benzodiazepines, the combination of substances increases GABA signaling within the central nervous system and in turn resulting in respiratory depression. Benzodiazepines may be used to reduce the effects of muscle spasticity, such as in the genetic disease myotonic congenita. Myotonic congenita is where chloride conductance in muscle fibers is reduced, finding sufferers experiencing muscle stiffness. For skeletal muscle to work efficiently, voltage-gated chloride channels are required. Chloride channels act as both anion channels and anion transporters. The voltage-gated transition depends on the arrangement of the voltage-dependent anions and protons. These chloride channels protopore independently. Voltage-gated chloride channels can be found in the T-tubules of the sarcolemma. This allows for rapid communication for muscle excitability. Action potentials that result in depolarization due to the influx of potassium within the motor neuron junction travel down the T-tubules. These action potentials activate chloride channels, which influence muscle fiber resting conductance to avoid the excitable effect at the sarcolemma. So, in summary, GABA is an amino acid that acts primarily as an inhibitory neurotransmitter within the central nervous system and it inhibits the firing of action potentials. Benzodiazepine exerts synergistic effects, allowing more chloride ions into the cell, further blocking the firing of action potentials. The result of mixing Valium and alcohol may induce respiratory depression. The role of chloride ions in skeletal muscle is primarily to control muscle excitability. This is via the regulation of electrical conduction in skeletal muscle. And myotonic congenita is a pathological condition where chloride conductance in muscle fibers is reduced and sufferers experience muscle stiffness.